Okay, today is the description of the Mad Mouse lab. The Mad Mouse is a roller coaster, and so we are going to make a very simple little roller coaster, which is going to be made up of three functions. A line that's heading downwards. Can anybody give me the equation? Y equals negative x. That's a line that's heading downwards. Now it needs to be shifted up so that it touches up here at like 30 or so. Plus 30, there you go. There's your first function. Now you need a parabola, but this one's going to be a little more complicated because we want it to be shifted to the right and up, and so a parabola just of y equals x squared would not work. You'd need to do what? Shift it to the right and up. So like y equals, how do you shift it to the right? X minus, and let's say we go over like 10 or something, and then squared. There, I shifted it to the right. Then plus something, but notice it doesn't tell me how much to shift it up. So let's say I'm going to say plus 1. I don't care. Just move it up off the ground. Has to be off the ground. This is not known, but it has to be off the ground. Now, do you get that this, if you're actually making a roller coaster, this and this need to match and touch really nicely here? And you don't even know how to stop them from going forever, because right now, if you just graph the parabola like this, if you actually graphed it, it would just keep going forever. It doesn't stop. And some people think like, well, how can I limit its height? You can't. But you can say, I want it to stop here and stop here. And do you get how that makes it have an end point here and an end point there? If I make it stop this way, that's called a domain. We're going to give it a domain to stop it. So I'm going to show you now how to use a calculator. That's just a super quick overview of what we're doing. When it's done, you'll have three functions. One of them is a straight line with a negative slope. These are totally not the right answers, but this is an example of what would have to be in your calculations section of your lab write-up. Here's the quadratic, which is a parabola, and here is your square root, which is kind of the gentle ending after you've gone through the big dip part, your gentle ending where it tails off and slows down at the end. So here's your square root part. And again, this isn't the right answer, but it's something like that. Now this part on a calculator can be tricky to limit it and say, I only want it to be this function between two things. I think as soon as we do this on the calculator, it's going to make so much more sense to you. So would you please start by putting a parentheses around your x squared? By the way, you need to learn where the insert key is, because if you already had x squared here, I'm telling you, it's going to happen 8 million times that you're going to want to put something into your function that isn't there. So insert is awesome for that. I'm going to go back to the beginning, and right in that spot, in the first spot, I want a parentheses, but I don't want it to wipe out the x squared, because you'll have a big, long equation there. If you want to go back and put parentheses in, you need to know the insert button. Do you know that right above delete is ins, as in insert? So we want to go to second, above delete is insert, a parentheses. Get how you can insert the parentheses without having to wipe out everything you typed? All right. Now if I do this, and then I just say, I only want this to happen, let's say between -2 and +2. I want it to cut it off right there. Then I want to say in parentheses again that x, everybody follow me on this, type this in. Get your parentheses around your x squared first. Then put a parentheses around x and say less than. It's on the test menu. Look at where the red button is right now on my screen. It's right above that. Right above math is test. That'll give you the less than sign. I want x to stay less than 2. End the parentheses. And another parentheses around the other requirement. What was that? Yes, x greater than, also on the test menu. Greater than is the third thing there. Greater than -2. Don't forget to use the negative key, not the minus key. Enter. And I hit graph. Look at that, it stops it. Now, what if this is all fine, except I really wish it was moved over to the right? Everybody move it over, right, 4 spots. You should know where to put that in the equation. If you're having calculator issues, raise your hand and I will come and help you. I'll pause while we do that. If you have an older calculator, this has come up already, that kids will have it connected here and here. Raise your hand if that's you. Okay, now we know who has the old calculators. That's all there is to it. If you have a TI-83, it connects those. It's not like your calculators failed and you need a new one because of that. It's just they figured out a way to, in the software to not make it connect the 2 lines. In the old days, it had to be one continuous line. You get how there's a gap there? And the calculator couldn't handle that in the old days. Now the newer calculators can. So if you've got a TI-83, it just connects those 2 lines. All right, good. I got a few people's calculator issues solved. My next goal for you is that to move it over to the right 4. So hopefully you went in here and hopefully you knew how to insert again. Insert parentheses around the X. That's why I was teaching you that part. And then we're going to say insert again a minus 4 and the parentheses like that. And that should move it 4 to the right. Graph and see if it did. All right. Now I want you guys to think about what happened. It did move 4 to the right. It did. Yes? I gave it limitations. It's only supposed to graph it from here to here. So now we need to move those limitations over. So now let's say that we want it to go from 2 to 4. Or maybe 2 to 6. Let's say 2 to 6. We want it to like show us this part of the graph. So move the limitations, the domain, to bigger than 2 and less than 6. This is exactly what you're going to be doing for the lab. You're going to be going, okay, wait a minute. Why can't I see this thing? Bigger than 2 and less than 6. I'm going to go less than 6 first here. And bigger than 2. My program just died. I'm going to try to make it graph it again. Pausing. Oh. All right, so we can still see it. It's actually down here. That's like my alternate, my second screen of it. And that's what you guys have too, right? I was just kind of guessing where I should limit it to make it nice and like level so that this and this match up. What is a suggestion? Does yours work? All right. So does yours have nice, is it nice and like even like this? Okay, good. All right, then my computer just froze there and I'm gonna pause and get that fixed. All right, so I've got my calculator back again. I'm gonna have you type in a new equation. And this is a lot more like what the Mad Mouse lab is gonna be like. So let's do one more little like learning session on the calculator. So type in exactly what you see here on the screen. All the parentheses have to be right. All the less thans and greater thans have to be right. And if you get that all right, when you graph it, you'll see a little parabola that the challenge will be to try to match up a different graph and make it touch our parabola just right. So copy exactly what you see and I'll pause until you guys get that in. Okay, I was able to check and pretty much everybody now has it, maybe down to one person still struggling, but is getting there. So now, if I hit graph, I see a little U shape. What if that's the bottom of the roller coaster and your next job is to make a square root function that sits right on it? Do you get a normal square root function is here? So therefore I need to take a square root and move it where? Over how far? 1, 2, 3, 4, 5, 6 to the right, and up to, and make sure that you cut it off. This is important. Cut it off where x is, let me think, 11. No, 9. Cut it off where x is 9. So in other words, make it stay less than or equal to 9. If you're done, when you're done, your square root that you're going to type into your second equation line there should be just like this green one right here. It stops. Touches nicely, but stops right at x equals 9. All right, that's your challenge for the next couple of minutes. If you need help, ask the kid next to you. They're your first cry for help when it comes to technology. I'll come around too. Okay, I've got a lot of people who have their equation done, but they didn't put a parenthesis around the whole thing at the beginning and at the end to set it off from the little x is less than or equal to 9, and the other one, which was x is greater than or equal to, what was it, 6? All right, look at your y equals compared to everybody else's, and eventually you'll figure out what's different, because there's always something. I'll pause for a second when we try that. Okay, so if you want yours to look like this, which is what I was kind of going for there, the little red one, a square root that has been, it stops at 9, then this is the equation you would want. It's been shifted 6 to the right and up 2. And the parentheses, because the whole thing needs to be in parentheses. See, there's the first parenthesis, and then here's the ending parenthesis right there. Okay, then you need separate parentheses on your domains, which is x is less than or equal to 9, x is bigger than 6. Could have said bigger than or equal to 6, doesn't really matter too much. Why did they need the 6 part? Okay, you know what? In this case, this one of these supposed functions that doesn't go to the left, so you're correct. It would have been fine to not even say x is bigger than 6, because if it wouldn't have been bigger than 6, the function wouldn't have worked anyway. All right. So, long story short, it's done. It worked. And now what if, oh my gosh, I just realized from the lab that everything is way too short. It should be shifted up another 10. Wouldn't it be that pretty easy to shift everything up 10? Yeah, you find the first function, shift it up 10. Find the second function, shift it up 10. It really isn't that hard to do if you have to tweak it from there. So your job then is to do just that. Let's look at this. We're going to make 3 different functions: a straight line, the parabola, and the square root function. My advice to you is start with the parabola. Start with a parabola. They're easy. Move it to the right. And I don't know exactly how far you should go. You have to pick these numbers down here. Some kids, I will warn you, we're using like 50 and 70 for those. Like if they were thinking it's a real roller coaster and that part was going to be like 20 feet apart or whatever. Those numbers get so big that it was really hard to see the graph. You'd have to change your whole window and everything. So my gut says, if I remember correctly, last year, a lot of the kids ended up somewhere in the like 20s and 30s or even 10s and 20s. So maybe if you made this 15 and you made this 25 or something that's not huge numbers, but it lets you pick whatever you want. So if we were going to shift this thing over, you'd pick something between 15 and 25. Like what? Like maybe shift it over 20, and it doesn't say how much you want to shift it up. So you shift it up however much you want. And then cut it off at, let's say, 15 and 25. It's good to get a plan a little bit on paper so that you can then say, okay, so where should I shift it? Once you see it on paper, it's not that bad. Then, once you got your little parabola done, you'll need to do the same thing. Find a square root that touches it perfectly But it's got rules. It has to end at 25. The height at the end has to be 25. So you stretch that thing until it ends up at the height that you want it to be. So if it starts out like this, you just have to stretch it up. Do a vertical stretch until it hits just where you want it to. All right, last question I get a lot is, how do I make them match up really nice here? You just got to keep playing with it. But one way you can tell if they're really close is by going to the table. If you go to table, you can see where the one leaves off and the other one starts. And if the one stops at 10 and the other one starts at 10, you know they connected. Okay, you can tell how far off you are in the table area. All right, so here's some rules. The only real rules you've got. They're all on this page. So it says that you have to use a straight line for AB. That's from here to here. That has to be a straight line. So that'll be like negative x or negative 5x, or you have to figure out how big the slope is. And it's got to touch at, A is 30 feet. That's got to be at 30. That means the y-intercept of that line has to be 30. Yes?
Okay, the picture, like A isn't at the y-intercept?
You're right. There's supposed to be a little bit vague because we don't want to just give you all the exact spots to put things, because sometimes you need a little room to be able to play with it. So if you want to, look, there's a gap here. You can have a gap there if you want to. If you want to just have your line start at 30, you can. This D, the only thing I wish I would have drawn a little bit better is I wish this D were up here, because the end of that is supposed to be at 25. Where that thing tops out, where your roller coaster comes to a stop, is at 25. Okay, so if I were you, start with this part right here. We already did one in class. Get it shifted over, cut it off, maybe make this 15 and 25 or something like that. And I shouldn't say that. Many people have asked me, how can I get my parabola cut off this way? You can't. But you can cut your parabola off by stopping it here and here. You can have x limits on it. That's called the domain. By limiting it left and right, that's what makes it stop going up anymore, is by these kind of limits. Okay, so you say x has got to be less than 25 and x has got to be bigger than 15. That kind of thing. All right. When you're done, let me tell you a couple common places people lose points. Okay, I would strongly recommend that you look up for a minute and listen. So I know you're doing an equation, but you're going to miss really good stuff. All right, so here's where people lose all their points. They don't take a minute and go back and look at this and say, oh, I needed a purpose. If the person who's grading it can't find the purpose, you'll lose 2 points right off the bat. If your purpose is a copy and paste of what it said before, you lose 1 of the 2 points. You should summarize this in your own words. Realistically, do you want to recopy all of that and type it back in? That's kind of dumb. Say it in your own words. Next thing, the sketch. Notice the sketch says include labeled graphs. When you take a picture with your calculator, which, yeah, you're going to use a picture on your calculator, and it's going to be like this. When you take that picture, it's not going to have labels. So paste it into your document, and you better put labels on it, otherwise you're going to lose points. Because it says right here, you got to have labels. All right, next thing is procedures. Procedures is in words. That's where you say, here's what I did to solve this problem. If you haven't got it written out, and why not just call it a procedures section? Then the kid can find it. If they can't find the thing you're calling your procedures, then they can't give you points for it. And the last thing in the calculations section, that's where you need to have one of these. You have to write this out by hand and show me a piecewise function that's got the domains and everything for one big piecewise function. That needs to be in the procedures section. Or no, sorry, your calculations section. That's where that big graph goes. 3 parts and the domains for each. Okay. And then in conclusions, a lot of you forgot to list 3 things you learned. Just look through it when you're all done and check it yourself. Like, act like you're the one who's grading it. Read each of these little things and, oh, crap, I didn't state a purpose. And you can go back and save yourself some points. Or, oh, I didn't do 3 math reflections. Then maybe you should, otherwise you're going to lose points. Okay, so there's my tips for trying not to lose too many points. If you're going to get a 20 out of 20, these puppies better be just as close as mine are. They have to almost perfectly match up. And they have to be right at 10 for the height. If they're not, move it up until it is. Or move it down until it is. Yes, you're going to use your iPad and take a picture of your graphing calculator for this part. But like I said before, you have to label it. Otherwise, in the directions, it says right in here that it has to be labeled. So some people I know are going to say, but you said we could take a picture. Yes. And I also said you're supposed to label it because that's what it says to do. All right. Any other questions? Yes. This is due on Monday. Now, tonight is no other homework except this. So my recommendation is do it tonight. Okay, so it's due Monday. So most kids are that aren't going to be gone are going to be taking the test, normal test, not on this topic, but the normal test we have been doing on Friday. And then over the weekend, you're going to study for the top 20, which happens Monday in class. And you're also going to study for, or put it this way, you're going to finish up this lab. Both things are due Monday. Okay? All right, there's my thorough explanation of how to do this lab.